Hello, Math 7 students. This is proportions and non-proportions, part 2. Again, we are choosing different parts of Utah Middle School Math Project 4.2g and Open Up Resources 7.2.7, dealing with proportions and non-proportions. Here's a review of a past video. You have this warm-up, this quick pull. I want you to choose all of the proportions. We just have a bunch of graphs, a bunch of lines. I want you to choose the ones that represent proportional relationships. Pause the video so that you have given yourself a chance to do this, and we'll go over it when we return. All right, let's just go around. In the quick poll, I had 3 students who chose A. A is incorrect. Why is A incorrect? And why do you think students might have made the mistake of choosing it? Do some error analysis as well as error correction. Grant, you haven't even been here for a little while, so let's hear what you have to say. Yeah, it doesn't go through the origin. Exactly. It doesn't go through the origin, so not a proportion. Why would somebody have chosen it? Why do you think someone may have chosen that one? Any ideas? Grant again? It is going at a constant rate. It's a nice straight line and it's going at a constant rate. And I think that there might be another reason, and I'll explain my other thought on that one in just a second. B, I had just one person who chose B. B is not a proportion. Once again, just like we said on the previous one with A, B is a screen line, and B does not go through the origin, right? It goes through the y-axis all the way up here. It also is going at a constant rate, so perhaps that's the reason why that student may have chosen B. D, I had 9 students who chose D. D is correct. We should have chosen D. D is going through the origin, and it's a nice straight line. It has that constant rate where it's going up consistently. Looks like we go up 1 every time we go over 2. So D is a proportion. Or, I meant to say C. Sorry, C. D, we had 10 students select it, and that one is also a proportion. So we'll talk about both of those at the same time since I made that mistake. Both of them are going through the origin right here, right? They're going through the point 0, 0. This one is going up at that constant rate. This one is going down at that constant rate, but both C and D are proportions. So now let's kind of talk about why maybe students would have chosen A or B instead of C. Why do you think they would have chosen A or B instead of C? Quick discussion at your tables. Let's see if we can find mistakes in their thinking and make sense of that. With your groups, ready, set, go. Okay, and what are your thoughts? Why would somebody probably have chosen A or B that don't go through the origin instead of C? What is the thought process behind that, Carter? Yeah, B is kind of close to the origin, so maybe they just weren't paying close enough attention. Any other thoughts? In all the lessons that we've done, when have we seen a graph going down? Have we seen that? Not until now. Does it matter though? Does it meet the qualifications of a proportion? Is it a straight line that goes through the origin? Yeah, so we would have checked that one. So I am guessing that students probably chose A or B because they're going up. And they're like, oh, it's definitely not C. We've never seen one going down. Okay, so don't worry about that. We don't care if it's going down. Is it a straight line? Does it go through the origin? That's all that really matters. So C and D were proportions and the others were not. Let's continue on with our proportions and non-proportions. Just a quick review of what we did in our last video, since this is part 2 of this lesson. What we saw for the first time is a side-by-side comparison of a proportional and non-proportional relationship. So here we saw a proportional relationship and what it looks like in a table, and we also saw non-proportional, what it looks like in a table. From there, we were able to graph and see that the proportional, as usual, goes through the origin and it is a straight line. The non-proportional did not go through the origin. We also were able to write equations. We saw an equation of a proportional relationship is in this format where we're multiplying x by our constant of proportionality, and it's equal to y. And here we're seeing we still are multiplying by x, but we've got this extra piece here, this addition. We saw another side-by-side comparison of proportional and non-proportional, and again seeing those same characteristics. We were able to really summarize all the things that we see when we're looking for proportions, no matter what that representation is, and how to identify if it's not proportional, no matter what representation we're given. So with that in mind, we're going to practice this a little bit more. Moving on, number 3, the graph shows a monthly charge for a cell phone based on the number of minutes used. This time we're not going to start with the graph. We're not even going to start with information in a story to be able to put into a table. We're starting right here with the information in a graph. So we need to be able to read that graph and be able to place that information in the table and then answer the question that follows. Is it a proportional relationship? Based on our experience, I'm going to let my students in class have a head start working through this so that they can contribute to the class discussion. If you watched the last video, I also want you to pause the video and give this a try on your own first. Ready, set, go. All right, students in class have given this a try, so they're going to help me fill out the table. With this information in the graph, how am I going to fill out the table? What do I do? Thanks for getting us started, Luke. Great. So we can see right here at 0 minutes used, the charge is $10. So 0 minutes used, charge is 10. Good. How do I find the next spot on the table? Cambria. Great. Yeah, perfect. So we can see that this is scaled to where every second one is labeled as 1,000. So half of that is going to be 500. So there's that 500 minutes used. We're going to go up and we're going to find that. It says 20. So 500 minutes used is going to be a charge of $20. You got it. Let's go one more student helping me out for the next one, and then we'll fill out the rest together. Tanner? Great. So we go over to 1,000, climb up until we hit that line and we see that 30. So 1,000 minutes used is going to be a charge of $30. Very good. So continuing on, again, between 1,000 and 2,000 is going to be that 1,500. At 1,500, that's going to be $40. 2,000, that's going to be the point $50. And 5,000, we skipped ahead. Oh no, I don't have the information that I need here, right? So what am I going to do? How did you guys work through this? Luke.
So what I did is, instead of like expanding the graph and just going crazy, I noticed that we already had 1,000 in it.
Okay.
1,000 was associated with 30. So if we multiply both of them by 5, that should give us the answer.
Okay, so you're saying in order to change a 1,000 to a 5,000, we just multiply by 5. So I'm going to take this 30 and multiply it by 5, and that's going to work, right? Let's test that out. Let's test that out with other information that's available on the table. What's the relationship between 500 and 1,500? How does a 500 turn to a 1,500? Times 3. Does that work here? 20 times 3, is it 40? No, it doesn't work. Why? Exactly, it's not proportional. Since it's not proportional, we don't actually have equivalent ratios. So, is it going to work down here? Nope. It's a really good guess. I love talking us through that. But we have been so spoiled with all of our previous relationships, knowing ways that we can manipulate around it because it's proportional, and now all of a sudden it's not proportional, so that's taken away. So we need a new strategy. Anyone else have a new strategy? Give it a try, Alexis. Okay, great. So you did kind of extend the graph, but you extended the graph with some really logical thinking about how the numbers are all related, right? So you're saying the graph stops at 4,000, but I know that's going to go 2 more spaces here to get to 5,000, right? Which means it's going to jump 2 more spaces here, meaning here's that 100, and this is going to be the number 110. Is that correct? Okay, yes, that is some good thinking there, 110. And do you see when we do that, we're getting a different number than when we tried to use Luke's strategy for proportions, because this one isn't proportional, right? Here's some other ways that we can do this. I just want you to be comfortable with things that we're seeing in the table, and this again gets you to that 8th grade level of thinking. Each time the table jumps by 500, how much is the charge changing? what if the table jumps 1,000? So 1,000 to 2,000, it jumped 1,000. How much did the charge change? 20, and that makes sense, right? It went 500 and 500 again, so 10 and 10 again. So now we can make some leaps then. How much is this changing? 2,000 to 5,000. How much is that changing? 3,000, right, Leroya? I heard you say it, now say it out loud. And so how much is this going to change? Of course, we already have it filled in from Alexis's information. Let's get rid of it for a second. If this is going to jump 3,000, how much is this going to jump? Let's see, when it jumped 1,000, this jumped 20. Now it's jumping 3,000, so now it's going to jump 60, which means we're going to end at 110. Great. Nicely done. Okay, and so with all that in mind, we've already answered this question. Is this proportionally related? Is it a proportional relationship? No, it's not. We saw a couple of different ways. No, it doesn't go through the origin. But we also saw in how we had to look at the table. We had to look at it in a different way, right? The table didn't have equivalent ratios. We couldn't manipulate it the way that we wanted to. Great, and now we're on to the Open Up Resources part of this lesson, Open Up Resources 7.2.7. So that would be Unit 2, Lesson 7 from Open Up Resources. Entrance to a state park costs $6 per vehicle plus $2 per person while in the vehicle. So with that in mind, how much would it cost for a car with 2 people to enter the park, 4 people, or 10 people? We can answer those questions just by filling out the table here. Don't jump ahead to parts 2, 3, and 4 until we have correctly filled in this table. I'm going to ask you to pause the recording, give it a try on your own, and then we'll go over it together as a class. Okay, so with this problem, again, rereading it one last time before we get started on all together, $6 per vehicle plus $2 per person in the vehicle. So I see 2 people in the vehicle, $2 per person. That's going to be $4, right? What's the mistake that I just made? What did I do? Bella? Exactly. Yes, it's $2 per person and there are 2 people, but we still have to pay that $6 for the vehicle. Okay, so we need to make that adjustment. Yes, this is 2 times 2, which is 4, but we need to make sure we're paying that $6 for the vehicle fee, which means it's actually going to be $10. Let's follow that same strategy. 4 people in the vehicle, so yes, that's 4 times 2, which is 8. But don't forget, we still had to pay the $6 for that vehicle. So 8 plus 6 is going to be $14. Same thing, 10. Now this is a big giant van or maybe a small bus or something. Still, $2 per person in the vehicle. 2 times 10 is going to be 20. But don't forget, we have to pay for that vehicle to be in the park as well. So 20 plus 6 is going to be $26. For each row in the table, if each person in the vehicle splits the entrance cost equally, how much will each person pay? I want you to understand what that's really asking. What it's asking is look at the relationship in the table a little bit differently than we have before. Or maybe we have, we just haven't emphasized it. So to make sense of that, I want to come back to this problem here. Let's check the amount of water in the pool for each minute. So let's check with Barb. How many gallons of water in the pool? 4? Over how many minutes? That is going to be right here, 4 over 1. What's 4 over 1 simplify to be? Just 4. What about here in the table? 2 minutes have now passed, but there's 8 gallons of water, so that's 8 gallons per 2 minutes, which is equal to 4. Same thing here. 12 gallons of water over 3 minutes is equal to 4. So we're seeing the same thing here. Why am I seeing the same thing here? Because that's our constant of proportionality. Let's check it out over here. 10 gallons of water and 1 minute has passed, so that's 10 over 1, which is 10. 14 gallons of water over the course of 2 minutes, so that's 14 over 2, and that's equal to 7. 18 gallons of water over the course of 3 minutes, 18 over 3, that is equal to So we're seeing that this number is changing when it is not proportional. So with that in mind, when it's asking us to compute the cost per person, if everybody in that vehicle is splitting the cost, how much is each person paying? We're saying here, this is going to be $10 split among 2 people. That's $5 per person. But now it's $14 spread among 4 people. How much is each person going to pay? 14 divided by 4 is equal to, I know some of you guys already have it calculated. Some of you guys are just typing it into your calculator. Luke, did you get 3.5 or $3.50? Great. So $3.50 per person. When there's only 2 people, it was $5 per person. Now, what if there's 26 people? Or sorry, it's costing $26 and there are 10 people, so that's 26 over 10, Grant, $2.60. So notice what that really truly means, and notice the relationship between these numbers. We're seeing that an attempted constant of proportionality here is changing. It's not constant. 4 times 350 is 14 because each person would be paying $3.50. So this further confirms question number 4, is the relationship proportional? The answer is no. We don't even have a graph this time, but we saw the information that we needed in the table. No constant of proportionality. I'm going to let you work on number 3 for just a second. Number 3, hopefully by now you're already noticing some sort of a pattern here. So what if instead of 2, 4, or 10 people, what if it were 50 people? If it were 50 people, how are you going to determine the cost? Once again, if you can answer this question, you're leaning towards that 8th grade level of thinking. So I'll pause the recording, let students work through this with their groups. We'll come back together in about 30 seconds. Ready, set, go. Okay. How are we going to determine it if it's 50 people, Sophie?
So I did 50 times 2 and then I added $6 per vehicle. I got 106, and then I divided that by 50. I got $2.
Oh, good. If we were going to divide it by the 50 people and find the cost per person, yes. It's just saying, in general, how much for that whole entire bus full of people. So yeah, we're going to stop here, and that's great. How many of you guys got the same answer? Good. You're thinking like 8th graders. Let's go a step further. What if, instead of 50 people, what if I said X people? Changing it to a variable. Our strategy shouldn't change, right? What is that going to be? Liv, give it a try. Yeah, 6 plus 2x. Because no matter what, we're paying the $6 for that vehicle plus $2 times the number of people. The number of people is just x. That's exactly right. And that is going to give us our total cost, which we're going to call y. So you guys can write equations like 8th graders. Nicely done. And now it's time for our cool down and summary. In the cool down, we have a couple of different tables and a couple of different situations. Based on the information that you see, you need to determine, are these proportional relationships or not? So here we have pounds of apples, 2, 3, 4, 5, cost of apples, and these different costs. Is this a proportional relationship? Before you answer, what are some things that I should be looking for? How am I going to determine if it's proportional or not? Luke.
Constant of proportionality.
Yes, if I can find a constant of proportionality, then I know it's proportional. No matter if it's this situation or this one, if I can find that constant of proportionality, then I know it's a proportional relationship. Some of the other tricks that were mentioned before, I think it was Cambria who said, if it goes through the origin, if we have a 0, 0 on the table, that's a good start, right? Unfortunately, it didn't give us those zeros. So we can't use that trick. We have to look for that constant of proportionality. So with your groups, find out if either of them are proportional, and then you can answer question 3 after that with your groups, and then we'll come back together and talk. Ready, set, go. All right, you guys said we can look for a constant of proportionality. I'm trying, but I don't know how a 2 changes to a 3.76. All the other numbers that we've had have been really nice and easy to play around with, and I can do mental math, but I don't know how a 2 changes to a 376. So what do you suggest I do? Cambria?
I would say you
let's work backwards. 376 divided by 2. Fun fact, isn't that what that other question was asking us to do? Right here. Yeah, exactly. We didn't realize it, but it was asking us to work backwards to find that constant proportionality. And here, we already know when I can't go forwards, when I don't know how, I work backwards. 376 divided by 2, what do you get when you do that calculation? When I go backwards and do 376 divided by 2. Cambria, go ahead. Great. So now I know 2 times 1.88 is 376. Let's test that out everywhere else. 3 times 1.88. Does it give me that 564? Yeah? Did you test it everywhere? It's a good idea too. Sometimes it feels a little bit redundant, but I know what's coming next in your future, so let's make sure we check it. 4 times 1.88, is that 752? Yeah, and 5 times $1.88, is that 9.44? Yeah, so we found the constant proportionality. The constant of proportionality was $1.88 or 1.88. And number 2. Again, I don't know how a 2 changes to an 11.99, so I'm going to follow Cambria's strategy. Let's work backwards. That's going to be 11.99 divided by 2. Help me out with that math. What did you get here when you did that? Alexis, go ahead. 5.995? Okay, thank you. And does that work here? 3 times 5.995, is that going to be 1349? No, that's not going to work. And as soon as it doesn't work, there's no point checking anything else. We know that there is no constant of proportionality. So, question 3 says, write an equation for the proportional relationship. There's only the one proportional relationship. Let's write that. If I'm going to call this the x and this the y, when I have an x, I'm still going to go forwards in that table by multiplying by 1.88. So I end up with x times 1.88 is equal to y. X times 1.88 is equal to y, or even better, if we write it y equals 1.88 x. Let's summarize. Here are some prices for some smoothies at 2 different smoothie shops. You can see it all listed here in the table. For smoothie shop A, smoothies cost 75 cents per ounce no matter which size we buy. There could be a proportional relationship between smoothie size and price of the smoothie. The equation is P equals 0.75s. When we find the unit rate, that unit rate ends up being the same thing as that constant of proportionality. This is kind of a weird sentence to add. It says the relationship could still not be proportional if there is a different size on the menu. So they're just saying, hey, just what's listed, it's proportional, but what if they randomly had something else that where you got a good deal if you bought more, then it wouldn't be. But I just want to focus on what's actually listed, whether that's proportional or not. For smoothie shop B, the cost per ounce is different for each side. Here, the relationship between smoothie size and the price is definitely not proportional. You can see that the more you buy, the cheaper per ounce it gets. These guys are giving you a deal if you end up buying more. And so it's definitely not proportional, and we cannot write a proportional equation for that. In general, 2 quantities in a proportional relationship will always have the same quotient. Why do they always have the same quotient? Because they always have the same unit rate, or they have the same constant of proportionality. When we see some values for 2 related quantities in a table and we get the same quotient when we divide them, that means they might be in a proportional relationship. Again, it's doing that weird thing saying, but if we can't see all of the possible things on the menu, then it might not be. But focus on the information that's given. And if they're in a proportional relationship, we can write that y equals kx equation, where once again, that k is that constant of proportionality / the unit rate. That is it for this lesson. Your homework, again, is a combination of 4.2g from Utah Middle School Math Project, and there are some problems from Open Up Resources 727. Okay, so just identifying, given some tables or some graphs, are we looking at a proportional or a non-proportional relationship? That's it for this lesson. Thanks for watching, and we'll see you next time.